Okay, so let's get started. We're going to be taking a look at working with our knock control within this training module, learning how the knock control works in terms of all the different tables, how it interacts together, and then ultimately what we need to do to determine the proper knock frequency for the engine that we're calibrating and tuning with our Motec. And Motec offers a really trick way to actually determine the proper knock frequency. It is going to be different than other standalone systems, so we're going to be taking a pretty in-depth look in this training module of how to actually determine that knock frequency. Now, my engine I'm working with in this training module is a Honda K24 engine, and I've fitted the engine with the OEM Honda knock sensor. So typically I like to replace the factory knock sensors with a Bosch flat response knock sensor, which are much better at determining more of a broad band knock determination than an OEM sensor. Now, the OEM sensor in this case is a resonant style sensor, where the Bosch knock sensors are going to be a flat response, more of a wideband type of approach for the knock detection. They work across pretty much any engine. This particular knock sensor will be a little bit noisier than we'll find that you will get from a Bosch knock sensor. But either way, we can calibrate using a resonant OEM style knock sensor or a Bosch flat response style knock sensor. So let's jump in here and take a look at what we have going on for our knock control programming and understand kind of an overview of how the system works. Ultimately, we want to utilize the knock control for more reactive type of engine fail-safe protection when we're running our engine hard on track. So if we have a knock event happen, we want the Motec to be able to pull back the timing from our main spark timing table to keep the engine safe, and then start to advance the timing back in slowly so that we don't have a knock event happen. We can start to essentially detune the engine on the fly. And what we can find is we can actually use the knock control to dial in our spark timing table. We'll look at that process in the next training module. But for right now, we need to set up and understand the actual knock control. So let's jump in here from our ignition tuning. Let's go over here to a knock tuning page and talk about a few things. Now, under our knock tuning page, we'll find that we have a bunch of different tables to take a look at here. We'll try to simplify this as much as possible. Ultimately, we need to determine the knock frequency before we can actually really activate and utilize any of the knock programming. But let's just learn real quick how this all fits together. So first things first, we have a knock threshold table. The knock threshold table is going to be determined based on our knock sensor's output. Now, we can determine the threshold that's appropriate for our engine based on running our engine in no knock conditions, where we have really low spark time and we know the engine's not knocking, to be able to populate our table values out. And then we can go in and actually start to advance our timing and then see if we overstep our knock threshold. If we overstep this threshold here, the Motec is going to have the authority to remove however much timing we specify in our limit table. So we have our main spark timing table calling out our spark timing, let's say at wide open throttle here at 20 degrees. And then we find that we have a knock event. If we overstep our threshold values, again, I put the values all at 100 here just to get going, to bypass any effect of our knock control so we don't have to worry about it potentially kicking in and doing anything as we're trying to kind of set everything up here. If we overstep the threshold level, it'll then take a look at the retard amount and actually retard the timing. If we put 10 degrees in here, 20 degrees in here, it can take all of the ignition timing out against our main spark timing table, whatever we've called out there. So this is the limit of how much it's able to take away. What we have here is a gain, and the gain is going to be how quickly it's going to be taking out the spark timing. So the way that this is going to work is actually pretty simple. If our threshold value, let's say it is a value of 20, and we register a output from the knock sensor, a threshold of 30. If we have a gain of 100 here, every 1% step over the threshold will then take, if we have a, say 10 degrees in here, if we have a value of 10 degrees maximum, it'll take a degree out for every % overstep above the knock threshold. And then it'll go in here and we see a recovery rate. It'll then, if the knock goes away, if we drop below the threshold since we've reduced the timing down, it'll then start to advance the timing back in, bring it back into what we've called out from the main spark timing table at this recovery rate. So it's degrees per second. And we can see here again, knock trim gain. We typically want this at 100. That is going to have that kind of a 1-to-1 threshold. So if we overstep this 1%, then it comes into our limit table here and it starts to take that away as a function of that total amount that we have specified. So typically we find in our limit table, we want to populate something like 10 degrees is sufficient. And again, to begin calibrating and tuning with our knock control, we want our threshold table set at 100 here, and the gain also set at 100. Now, there are a few other additional things we need to consider here. We have a knock window, and we also have a start window. So the start window is going to be specifying when it actually starts to take a look at the knock sensor. We can see this is called out here as 10 degrees, ATDC, or after top dead center. This is going to be when we're on our power stroke. So we initiated the flame front, we have our combustion, we have our explosion, and we're finding that this is going to be where we start to take a look at the knock sensor. This is the total window. So the width of the window is then 60 degrees. We start at 10 degrees, and then we have it at 60. Now these starting values work for pretty much any engine, and I rarely have a need to change them. So I'll keep them always at a value of 10 and 60, especially starting out. I'm not going to go ahead and change anything there. Now the other couple additional things we have our cylinder 1, 2, 3, and 4. I have a 4-cylinder engine, that's why I have these cylinders up here. We have a gain. The gain allows you to detune a cylinder's reading so that all the cylinders are equal to each other, and it effectively makes the knock control much more effective, and then we can set our threshold much better. That'll make a little bit more sense in the next training module as I demonstrate setting up the actual knock control and then starting to dial our spark timing in with it. We can see that process from start to finish. So we're going to be leaving these at 100% per volt right now.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.